Assalamu alaikum rahmatullah. Welcome everybody to our tutorials from zero to hero mastering Autodesk Inventor. We are in tutorial 1 caster wheel project, and in this video we'll discuss how to assemble these parts together that we did in previous videos in this tutorial. So let's go to our Inventor and see. In Inventor, don't forget to go to your folder if you close it and start Inventor from the project file in the workspace folder. Here we'll use the default assembly. We are in assembly environment here. Okay, I click this home and I'll click on the corner in order to rotate triod XYZ. Okay, and this is my make it my home fit to view as we did in the part. In order to bring parts into assembly, we have two types of assembly: top up and bottom down. Okay, bottom down we are creating parts inside the assembly, and top up we are bringing our ready parts into assembly and assemble them together. To place parts, you have to click the place component. Okay, click the place component and it will direct you to your workspace folder, and we'll place the main part. It's the bracket. Click open. Always my main part or first part that I bring it to the assembly, I make it grounded at origin, which means the X, Y, and Z and the XZ, YZ, and XY planes, they are made the X, Y, and Z origin of the assembly. So I place grounded at origin. Right click and place grounded at origin. Can you see that my bracket here is grounded and we have a pen here? If you click anywhere, and then you can place more than one copy of the part by clicking on the screen. Click, and this is 1, 2, 3. Any click, it will create a copy. And here we have 1, 2, 3, 4, 5 parts. They are all brackets. Escape to get rid of this one. And we need only one. We don't need these. As I explained, the assembly constraints and degrees of freedom, the grounded part has 0 degrees of freedom. It can't move, but these are free parts. If we go here to view degrees of freedom, we can see that they are free parts. We have 3 translation and 3 rotation. Okay, then they are free to move. How to get rid of these? Just switch off this one. Click on these by control, select all of these and hit the delete key on your keyboard. Save. And we'll save it the same name with the same name as the project, caster wheel. Click save. Next, let us bring the other parts, place, and I'll place the wheel. This is my wheel. I put it anywhere. Escape. I need only one wheel. Place. I'll bring 2 bushes here. 1, open. This is the first bush. Of course, you can put the bush here, or you can orient it. Then right click to orient, and you can rotate by 90 degrees around X, Y, and Z. We rotate it around Z. Then Z1 90 degrees, again 90 degrees, and it's okay, mating the wheel. Of course, it's not that necessary. We need only 2, so we'll hit escape. In order to assemble these parts to the wheel, okay, let us make a wheel grounded first. Click on the wheel, right click, and make it grounded. Okay, so we want to put our bushes inside the wheel. Okay, we'll use our constraints. First, I'll use mate constraint. As I told you, mate constraint, it can constrain points, axis with axis, or face with face. Let us switch on our degrees of freedom, view, DOF, and we can see we have 6 degrees of freedom for each. So of course, this is grounded. Let us apply our constraint and see what will happen. Constraints, mate constraint, I'll make this axis. You just go inside the cylinder to click, and this is the axis. And I click on the cylinder of the bush. This is the axis. Okay. Here, if you switch this on, check it on, and this check it on, this one will give you a preview of the show preview, and he'll show the distance. Okay. Of orientation, offset of distance. We need it at 0. We click apply. Now you can see that this, let's cancel. Okay, you can see that this bush have only 2 degrees of freedom. It's rotation, and it can translate along Y only. Then by applying this constraint, okay, we freeze 3 degrees of freedom. Suppress, let us see, freeze or take out. Okay, then we take out, sorry, the translation along X, the translation along Z. It can't go on the X direction. Can you see? I'm moving, trying to move. No. This one, it can go. And the Z direction, it can't go along Z direction. Okay, and the rotation the same way. So here, degrees of freedom give us that this part have 2 degrees of freedom. Now we need to put this face on this face in order to put it in. So you go constraint again, mate, opposite faces. We click on this face here and click on this face here. Don't click on the circle, click on the face. What's happened? We need the offset distance 0. So this is my part this way. Click apply. It still have 1 degrees of freedom. It rotates. If can you click it, it rotates around the wheel. We don't need it to rotate around the wheel because we have, that will I explain later. We'll put it. Okay, we give fit tolerance here. I need my bush to be fit inside the wheel. When it moves, okay, they will move together. In order to do so, then I'll go to off bush and click the plus sign, click the origin. Here's the bracket. Open the origin of the bracket. Then we have planes x1. Sorry, which bracket? We'll go with the wheels. Sorry. It's constrained with the wheel. Open the wheel, yes. What we'll do, then we'll mate XZ of the wheel with the XZ of the bush. And freeze the last degree of freedom. Let's go to constraint, okay, and take the XZ of the wheel, the XZ of the bush. Can you see? Then we are made them together. The distance is 0, click OK. And now my bush is 0 degrees of freedom, which means it's stuck with the wheel. Any movement the wheel will do, it will go with it. So it will rotate. If it will rotate, it will rotate with the wheel together. The same way we'll add to another bush, but we'll use another constraint that makes our life more easy. Let us go to constraint, and here we will click the insert constraint. The insert constraint prevent. Let us add this constraint and see. In order to add it, it's cylinder inside cylinder. This is what we need. We'll take the neck of the wheel from here, and with your shift and middle mouse, click a rotation and take the neck of the bush. Let us see what happened. Can you see? Click OK. Then one insert gives us two mates. Okay. Only 1 degree of freedom. Still our second bush half. Okay, it's rotation. As we did with that one, we'll go to this part in order to understand what part you are working. We have two bushes here. What bush, this one or this one? You click the part and it's highlighted here. Open the origin and we'll again constrain mate XZ of this one with XZ of the wheel, or YZ. It's the same. Sorry. Not XZ, YZ. حكينا احنا YZ of this one with the YZ of the wheel. Okay, and we made them together. Click OK, and we have 0 degrees of freedom. 0 degrees of freedom. Save. Next, we'll bring our rubber. Where's my rubber? This is my rubber. Open. Escape. Again, it has 6 degrees of freedom. Let's go for constraint, and this time we'll apply tangent constraint. Okay, here inside, here outside. Okay, then we have inside case because we need this face. Okay, inside this face. Okay. Click apply it. But it comes from the outside. Can you see? Didn't go well. Cancel. Control Z. Again. Let's have it this way. And try to put our tangent constraint again. Tangent constraint, tangent, inside tangent, this face with this face. Click OK. They are tangent now together. And we need to mate this face with the opposite face from the other side of our rubber. This is the opposite face. Click OK. Now our rubber is constrained or assembled to our wheel. Still rotate. Can you see one rotation degree of freedom here? Let us prevent it because when our rubber rotate with our wheel, while our rotation, it will rotate together. Again, we'll add the fit tolerance to this one in order to prevent it from movement, from moving while it's working. Good. What we'll do the same way as we did with the bushes. So we'll go here, our wheel. Let us close the bush, go to rubber, and open the origin of the rubber, and take the YZ of the rubber. Okay, with the YZ of the wheel. There is my wheel, here is YZ of the wheel. 0, okay. Now it didn't move. 0 degrees of freedom for all of them. Save. Next, what we'll do, then we'll put all these inside the bracket. Before that, we have to stop the grounding of this part in order to move it. It's free, 6 degrees of freedom of movement. Okay, and we need what? We need to put this hole with this hole. So we have cylinder cases. So we'll go for insert. I will take this hole. Okay, again, shift with this hole. Okay, let's see. Click OK, and this is what we want. We only have rotation around Y, and this is what we need. Our device is working well. Save. Now we'll put our standard parts. In order to work with standard parts, you have to place. And here's our standard parts from Content Center libraries. Click the place from Content Center libraries and wait until it will be loaded. Here we have our filter. We can filter to any standard that we want. We need, our parts is ISO standard, so I'll click the ISO. Okay. Do you remember? We go to our standard, this is ISO. Let me make this a little bit bigger in order to read. And here we have hexagonal head bolt, ISO 40114, M10 by 60. What does this supposed to mean? Let us see. An ISO 4014 or 4014, and let's go here. We need a fasteners, we need bolts, hexagonal head bolts, and here we have 4014. Double click the 4014. Okay, click anywhere, and this is my 4014. Now this table of views, or we can thread description and nominal length. We need, let's go back and read M10. Then the diameter of my bolt is 10 with metric thread. M means metric thread. Then M10, and 60 is the height of bolt. 60 the length of the bolt, of the height. Okay. So let's go here and select, where is M10? This is my M10, and we need the length of 60. Okay. Click OK. So this is my bolt. Right click, click OK. Again, it's free. We have cylinder inside cylinder again. Okay, we'll go to the neck of the bolt from here and put it in the hole. Can you see? It's constrained. Yes. Click OK. But it have 1 degree of freedom still. Yeah. It can rotate. It can't move, but it can rotate. I don't want it to rotate. So what shall we do? Then again, we go here. Okay. Open the bolt. Cancel. Let's open the bolt. Here's my bolt. ISO M10 by 60. Open the origin of the bolt. This is my origin of the bolt. And it will be grounded in the bracket. Where's my bracket? So I'll close the wheel, I'll open the bracket, origin of the bracket, and take the XY of the bracket with the XY of the wheel, the XY of the bolt. Okay, so I'll go to constraint, XY of the bracket. Next selection will be XY of the. Click OK, and it have no degrees of freedom. It can rotate. Good. Of course, now it can rotate, but when I put my washer and nut. It will prevent him from rotation. Again, placement content centers, fasteners. Let us see what we have. Then we have next, plain washer, ISO 7090. Okay, 10. 10 is the inside diameter of the washer. Inside diameter of the washer, or the nominal diameter of the washer. Okay. Then 7090, do you remember? Let's go back. Washers, where's washers? Washers, plain washers. 7090, double click. Put it anywhere. I mean 10. Nominal diameter is 10. Click OK. Okay, let's just put it anywhere. Escape. Our washer have a chamfer. Okay, usually the flat face, it makes the bolt. So we'll go to constraint, again insert, again this one with the, oh sorry, cancel, with the, again insert. Okay, here with the hole on the hole. Click OK. Can you see the chamfered face will be on the nut? We don't here. It's not that important to make it not rotating. Still have one rotation smell. It's one rotation DOF. Placement content center again. I'll just have our nut. Where's nut here? Nuts, hexagonal nut, and just see the number of my nut. Then ISO 4035 M10. Of course, they will be the same dimension of the bolt in order not to go on the bolt, to screw it. Okay. Mash. M10, let's go and have M10. Where is M10? The number is 4035. 4035. Okay. And we can add it automatically. In order to add it automatically, if you can see down at the left lower corner, he asked me, Inventor, to select a threaded cylinder. So this is my threaded cylinder, the bolt. And now he asking planar face where my nut will be located. So I'll click the planar face of the washer. Automatically, Inventor calculates the diameter of my nut according to the bolt or cylinder that I selected. I click OK. Now I have my bolt, my nut, sorry. Let us see. Then he already take it M10. Okay. This is auto drop, we call it. How to make it on or off. If I go again, placement content center, we have here auto drop. If you switch it off, you have to put the part here and select its dimension manually. If you are switch it on, you can, as I did with the nut, so I can select the adjacent part, and according to this part, Inventor will calculate the dimensions or the diameter, the length, etc., of the other part. This way we are assembling our part. Again, we don't want this to rotate because we'll tighten it hard. So I'll go again to the nut. Here's my nut, origin of my nut. This is YZ of my nut. Where is it? YZ, sorry. XZ, we need vertical. Okay, let us constrain it with YZ of the bracket, as we said. Where's YZ of the bracket or XZ of the bracket? With XY the bracket. Now YZ. On the 0, the bracket, we are in the rubber. No, we don't need the rubber. Cancel. And second one will be with the bracket. Okay, then with the XZ of the bracket and click OK. Save. And this way, our assembly is ready. Let us check our device is working well or not. Okay, then in this case we are moving it manually. We can auto, and in this case we have to apply constraint, angle constraint, direct angle constraint, and we go to the wheel, close this one, close this one, close this one, close all of them, go to the wheel. This is my wheel. Take the origin of the wheel, and we need the YZ of the wheel, okay, with this face, and to create a zero angle, zero. Can you see? And when we have zero angle, and this constraint, I'll call it as drive in order to recognize it. This constraint will drive my assembly. I click OK. Now we can see that we have only 1 degree of freedom for what? For the washer. But the others are fully constrained. How to drive my assembly? Then I'll go back to my drive constraint, right click and drive it from 0 to 360. For example, by 2. Okay, let us drive. It's too slow motion. We can open these double dot arrows, give it instead of 5 degree, 1 degree, 5 degrees, or 10 degree. Okay, and we can here repetition. We can repeat it for 4 times, for example. Okay, let's see. So this is my assembly working well. We can see that our rubber is moving, but you can, if you come here, you can see it. Okay. This is the end of our assembly video. This is where we assemble our parts. We check that our device is working by driving our constraint. Thank you for watching. I hope you enjoyed it. If you have any questions, just drop them down. Keep tuned. See you next video.